Okay. So after the morning session, as per the schedule, we are moving to article discussion. Now I requested our coordinator, Dr. B.V. Sumangla madam, to introduce the resource person for the article discussion to the participants. Please, ma'am.
Yeah, good afternoon, everybody. Now we will start our your favorite activity, article discussion by our colleague, by our friend, Dr. Sridhar. He has put in more than 20 years of service in this profession at various capacities as professor and head of the department, and at present he is associate professor of the department. He has got many honors like RNS Best Teacher Award during 2009. He is the reviewer of various papers for international conferences, and he at various capacities he has worked as session chair and keynote speaker, and he is the reviewer for IEEE transactions on instrumentation and measurement. So like this he has involved himself in various research and other activities. And at present, sir is working on a project funded by the institution, and also he has written a book along with Rakesh and Mallikarjun on basic electrical engineering. So we are pleased to have you here, sir. So over to Dr. Sridhar, please. And on this, where is it, Dr. Purnima? Okay, Dr. Purnima is also here to assist Dr. Sridhar in completing this activity. Thank you very much. All of you have got the handouts now? Paper? Copies? Right.
Take one more. Here, no, everything. Take one more.
Hello. A very good afternoon for one and all. I thank Madam for the beautiful introduction. Thank you, Madam. Myself, Dr. Sridhar, yes, presently working as Associate Professor in the Department of Electrical Electronics Engineering. I am here today in front of you for the article discussion for the third day event. Before I proceed with the article discussion, I would like to share some pictures in front of you. What is this? Yeah, you can see a EV which is on fire. Next, during the transportation of an EV, there is a fire. Can you vaguely guess what the topic would be for the day?
Safety towards EV.
Fantastic. I'll be dealing with fault detection and diagnosis of electric motor drive and battery system for electric vehicle. Okay, so these are the authors, Mr. Muhammad Zameen, alias and Himanshi. So I'll be discussing the article on this title by these three authors. The outline of my presentation would be, I'll start with the types of faults that are normally there in EV. We'll be discussing the fault detection and diagnosis in EV. Finally, concluding remarks, and after that, I would like to present a small glimpse of the fault detection and diagnosis techniques that the Department of Electrical and Electronics Engineering, Ramaiah Institute of Technology, we are doing. So I want the session to be more interactive, and henceforth we'll have more discussions rather than me talking alone. I'm sure from day one you would have heard a lot of information. You have both inherent as well as the acquired knowledge about EV. Now, can you tell me what or where are the probable places where faults can occur in EV? Fantastic. Battery, motor, sensors, converters, yes? Inverters. So basically, can we classify the faults into three types? One is all major electrical faults. Second one, mechanical faults. And I group third one as a sensor fault. Okay? That is how the faults are being classified in this particular article. Okay? So now you can ask me, sensor is also a type of electrical. So you may have electromechanical sensors as well. So therefore, we have, the author has classified the faults basically into three types: electrical faults, mechanical faults, and sensor based faults. So that's our first analysis of the different types of faults. Now, to proceed in detail, we have electrical faults, we have mechanical faults, and we have the sensor faults. So, what are the probable electrical faults that can occur in an EV? It's there here. The tree that is being projected in front of you gives the complete details of all the types of faults. When we talk about the electrical faults, we are very sure that our EV major requirement is power supply. Then you have an inverter or a converter, okay, DC-DC converters supplying a motor. Okay, so I may have faults on the inverter side, I may have the motor faults. If you just look at this, you may ask me, where is the battery fault? Okay, batteries again, they have dealt it in detail as we proceed through the article further and further. Okay, so here they have only classifying the inverter faults and the motor faults. What are the different types of inverter fault? We have an open switch fault, you have a short circuit fault, okay? A switch may be a short, okay? Or we may have a DC link capacitor failure. So these are the probable places where the failure can occur in an inverter. When we talk about motor, what are the different types of faults that can probably occur in a motor? We have the interturn short fault, we have the phase short fault, we have the demagnetizing fault, okay, demagnetization effect, and you have a single phase opening fault. So these are the normal faults that occur in case of a motor. Now when we look at the mechanical faults, the bearing of the machine can fail, which is also a type of a mechanical fault. We have the eccentricity fault. What is basically eccentricity? We know that the shaft of a machine is normally horizontal. Now, depending upon the loading, sometimes the shaft gets slightly bent. This is what we call as the eccentricity. So we have an eccentricity which leads to unbalanced magnetic field in the machine. So this is a type of mechanical fault. We have a bent shaft fault. We have the damaged magnets, okay? Our magnets in the machine, electromagnets, they may be damaged. and we have the bolt loosening fault, which will again lead to one of the poles being failure there. So they are the mechanical faults. And coming to the sensor faults, I'm sure all of us are aware that there are a lot of sensors nowadays in EV. We have current sensors, voltage sensors, speed sensors, and many other sensors. So the failure in those sensors are also the faults. So in general, this is how the author has classified different types of faults. Now, coming to battery, the faults in battery are again dealt in detail. This is a very nice review paper because it gives the up-to-date review, latest review. It's a 2023 article, MDPI journal paper. So he has reviewed almost all literature up to 2022 and 23, latest 23 as well. So he says battery faults, 3 types, battery abuse faults, and actuator faults, as well as the sensor faults. Now, most of the time, we are aware of the sensor faults because we are measuring the battery voltage, SOC, SOH, everything. So you have a lot of sensors there which are sitting in the battery. So failures due to calibration of the sensors can happen. So we have voltage sensor failure, we could current sensors, temperature sensors could fail, giving us catastrophic or erroneous results. The actuator failures can happen. You have the battery abuse faults. The battery faults normally occur because of overcharging. You may have an internal short circuit. Basically, many a times thermal runaway. You saw the fire accident in those pictures. Most of the time it is because of thermal runaway that is happening in the battery. And we have the over discharge and the external short circuit. So these are all the reasons for the failures of the battery. Of course, actuator faults, the failure due to the connection, the cooling system faults, and the local area bus network failure would also contribute for the faults in the actuator. So all these are being basically classified under the battery faults. Now the question is, how does FDD, this fault detection and diagnosis, help us? Basically, let us try to simply understand the overall block diagram of fault detection. If you see, we have the input is not given here explicitly. It could be a simple battery. It could be a combination of fuel cell battery, which is basically given to an inverter, and your inverter is driving the motor, which is further connected to the transmission, goes to the shaft and further it goes on. Now, faults can occur either in the inverter or in the induction machine, or it could be a permanent magnet synchronous motor, okay, so or a BLDC motor. So the fault can either occur here or it can occur in the motor. So we are trying to detect the faults or the anomalies that can occur anywhere. So just imagine the number of sensors that you need to have. Okay, so today the greatest challenge is multi-sensor data fusion. It is not one sensor, you have so many sensors in and around your vehicle, and congregation of all those data and coming precisely to a single consensus of what exactly is happening. That is the greatest challenge today people are facing because of the abundant amount of information that is coming out of all the sensors, which are real time, processing that quickly and exactly determining that yes, this is the fault. This is the greatest challenge that the power engineers are facing for the day. So we have to detect whether the fault has occurred. If there is a fault, you have a fault alarm. Else, I say it is in a healthy condition and just goes on. Okay, so there is a continuous monitoring of all the parameters. So you could see previously the evolution of your FPD technology. We had what is called as breakdown maintenance. So once maybe an inverter or an induction motor fails, then we go for repair. Till there, nothing doing. We are not going to look into it. So what happened in the period of breakdown maintenance? You could see the failure rates were high. Till the failure occurs, there is no maintenance. But gradually, we could see that the maintenance technology changed from breakdown maintenance to preventive maintenance. So you could see that once in a year, a serviceman comes to do the service. Okay? So that is what we call as a preventive maintenance. We do not wait till the machine or the inverters are failed. And now the technology has moved further, what is called as condition-based maintenance. Okay, that is what just now I discussed. All the parameters are continuously sensed and monitored, so thereby the failure rate has been minimized to a great extent. So what does, if I have to do this condition-based maintenance, okay, what does it call for? If you just look into, it calls for three important stages. One is the data acquisition, then is the feature extraction out of the data, and then is the decision making. Now, what is this first stage data acquisition? It is a raw data that you are going to get out from the sensors. Okay, it may be in the form of voltage, current, whatever. So we have the raw data which is acquired through any sensors. Okay. Now, once the data is acquired, I need to have a pre-processing, that is what we call as a feature extraction. Sometimes the data itself may not be in a position, okay, to give us sufficient information. In that case, say for example, you were seeing yesterday that some of the time domain signal to frequency domain conversion have to be done, because in the frequency domain gives you a lot of information rather than time domain signal sometimes. So therefore, in such case, I need to have a transformation. So either I can do, what are the different types of feature extraction techniques? It can be a simple statistical methods for feature extraction, mean, standard deviation, kurtosis. There could be a simple feature extraction technique, or I can do in simple time domain technique, or we could go for frequency domain technique. So your Fourier transforms, FFT, or we can go for wavelet transforms, Hilbert-Hungary transforms. So many transforms are available with us, okay, which are through which we get the features, and finally we need to make a decision out of the extracted features. So how do we make a decision? If it is a simple demarcation, okay, it's very easy for me. My standard deviation value of a healthy machine is 2. My standard deviation value of a faulty machine is 100. I need not have any classifier. 2 is healthy, 100 is faulty. There's a lot of demarcation, there's a lot of boundary, which gives a clear indication that yes, this is healthy, this is faulty. Now suppose there is an overlap of information, say 2 and 2.2, 2.1. If this is the range, narrow range of standard deviation for a healthy and faulty, then it's very difficult for me to identify whether the machine has really failed or it is in the healthy condition. So therefore, then I need to have certain decision making tools. So what could be the decision making tools? Our decision making tools could be something like a neural network, as simple as that. Okay, you have an expert system, your fuzzy logic, okay, support vector machines, and nowadays a lot of big data analysis are coming up. So we can use any of them to extract or to make a decision based on the features that you are going to give as an input. Okay. Now for battery analysis, convolution neural network has played a very important role. You can see many papers wherein synthetic data have been generated for the battery, and they are able to predict the health of the battery using convolution neural network. So if you could see the fault detection and diagnosis method, basically 3 types: model based prediction, you have the signal based prediction, you have the data driven based prediction. So model driven, you have all the conventional methods like FEM. Just now previous speaker was talking about the finite element analysis method. You have the sparsity space equation, model predictive method, okay, and I think it's repeated twice, I'm sorry for that. You have the state observer, the parameter estimation. These are all the model based prediction. The signal based prediction, as now just discussed, it could be a time domain signal analysis, frequency domain, or both a combination of time and frequency domain analysis. For all these, It could be a current signal, it could be a voltage signal, it could be a vibration signal, or it could be a flux, magnetic flux. All these are what we get as an output of the sensors. So those sensor output goes for analysis, feature extraction, and then the classification. Okay? So now again, the data-driven model, wherein I can use fuzzy logic, neural network, machine learning, deep learning, many more. So I would conclude with the final concluding remarks saying that condition monitoring is surely a win-win solution for both consumers as well as EV industry at the end of the day. And as I said previously, what are the initiatives that the Department of Electrical and Electronics, Ramaiah Institute of Technology have taken towards FTD? I'll just briefly present. This is not a part of article discussion. Okay, I'd like to present just in 2-3 slides. We have been working on the condition monitoring of induction motor. Firstly, this was for the identification of the broken rotor bar fault. Okay, this is the hardware setup. Then the second initiative, we all of us know that each machine requires a single inverter to drive the machine. So basically, if you have 2 motors, you need to have 2 drive system, 2 feedback, DSP controllers, all the auxiliaries. We have now come up with what is called as a 5-leg inverter. It is not a very novel thing, it already exists in the literature. Okay, we have polyphase inverters. We are not talking about polyphase machine. We have a 3-phase machine which is being supplied by a 5-leg inverter and 1 leg is being made common. So that is going to reduce your switching losses, your auxiliaries. I have only 1. Okay, feedback is sufficient to identify what are the faults that could occur in the system. Okay, so we are reducing all DSP, all single DSP is sufficient to measure everything here. So this is the hardware setup that we have in our laboratory, okay, for the same 5-leg inverter, which we have recently completed as a RIT seed fund by myself and Dr. Kodeshwar Kumaran. And another initiative, this is a vibration setup analysis, is what we have done again by Dr. Kodeshwar Kumaran, and some of his students have done the vibration setup analysis. This is the induction motor. You have the loads that are put on the shaft of the induction motor to create artificial vibrations, and the vibrations are sensed and they are processed for the detection of any anomalies in the machine. Okay, so with this, I thank you for your patience hearing, and I thank the organizers for providing me an opportunity to briefly share about the happenings in the latest technology. Thank you. Thank you.
So, thanks to Dr. Sridhar sir for explaining about, for discussing about the article in circuit wise, and as well as what are the facilities or whatever the experimentation we have implemented by Dr. Sridhar sir and as well Dr. Kodeshwar Kumaran sir in the department are shown here and discussed. So now you have the articles with you. Please go through the article, then highlight the points. Finally, you make it the report. Thank you.
We are also open for research collaboration and grading PhDs. Anybody interested can contact the department.
We have
TV.